Night.
And we're live. Welcome back to another Corona Geek here where we talk all about mobile app development using Corona SDK. I'm your host, Charles McKeever. And today, we're talking about summer. We are making plans for the summertime. It's time to consider what those projects are going to be, what you're going to do for the summer. And I think some of them should be Corona SDK based. What do you guys think?
But I think that is inevitable.
Now is the time. There's no better time than now. So joining us on the panel is Dr. Brian Burton down in Abilene.
Hello.
You can find his books and other materials over at burtonsmediagroup.com. Also joining us is Ed Marina from roaminggamer.com. And also joining us is Sergey from spiralcodestudio.com. One studio.
From Russia with love.
From Russia with love. Yeah, absolutely. So thanks, guys, for joining us. We got a lot of stuff to talk about today, and I think we should just get right on into it. I want to make a couple announcements, but I told Ed we'd keep it short because we want to cover a lot of material. As they said in Smokey and the Bear, we got a long way to go and a short time to get there. So I want to remind you guys about Corona Geek 141, which was last week's show. We talked about creating and matching puzzle pieces. It was an informative show because it's one of those topics where you kind of scratch your head and say, how do they do that? And there were some illusion bits that were revealed and all that kind of stuff like that. So if you haven't had a chance, go check that out. The source code is out there. You can download it and play with it. There's some bonus bits about snapping pieces to edges and things like that. So go check it out. And you can find all the videos over at youtube.com/coronageek, of course. Someone emailed me just today, said that they were going back through and watching all the videos. They had been a fan of Corona Geek from the beginning, and I appreciate that. And there's a ton of great stuff out there from people in the community who have been on the show with us. So go check it out. Also, have you guys seen what Jason's doing? Jason Schroeder? Over at jasonschroeder.com, he is basically playing Boomdot against himself.
God.
So for May's Corona Geek Games, we're playing Boomdot. We'll put a link in the show notes. But essentially, Jason's gone out there. He's posted a series of high scores, and his latest one is 227. So he is the man to beat at the moment. Somebody popped in earlier today and posted a 223 score, which I thought was a really good run for the money, but Jason's playing against himself now. He's basically trying to beat his own high score. So if you can do it, then at the end of the month we'll announce the high score winner, and you might have a chance to win a $50 gift card. So your man to beat right now is Jason. So go check that out. We'll put a link in the show notes.
I got no hope whatsoever. I should just give up.
Well, he says, he spends a lot of time on the train, I guess, going back and forth, to work, and that's what he's doing. So
that's what I need. I need one of those things that lets me, really take a time out.
Yeah, right. Yeah. Oh, yeah, like a job.
Yeah, job.
I had a whole bunch of time. I didn't realize I had all this time when I had a job, a day job. So.
Don't even remind me. It's been 3 years now.
Well, I tell you what I do want to remind you about is that Daniel Williams has produced a Udemy course on Corona that is a game development Udemy course. It also covers ASO and adding ads to your apps. So if you are interested in something like that, go check it out. We'll put a link in the show notes, and you need to use Corona Geek, all one word, as the coupon code, and you'll get the course for $9. So I've taken the course. I'm probably about halfway through it, maybe, and it's good material, very good stuff. He does a Ninja versus what was that? Ninja versus? No, good Lord, Ninja versus something, and I can't remember at the moment. And anyway, he shows you how to get the characters on the screen, how to make a move, how to do buttons, all those types of things like that. So, and he's doing it the what we'll call the long form way. He's actually creating the buttons and stuff like that. I know that on some of our previous discussions here on the show, we've used library classes and stuff like that in order to kind of shortcut that process. But he's He's doing it the long way.
Explaining the concepts.
He is. So if you want to see the longhand form of the code, that's definitely a way to do it.
Not the Ed lazy one-line version.
Well, I think the one-line version is exceptionally good. But it's almost like anything else. As soon as you don't really appreciate it until you've seen the long version.
You put the effort in. That's right.
Yeah, yeah. Then you're like, oh, I definitely want to do that long. I want to do that one line.
I don't want to do that anymore. That's what I say all the time.
Right. So go check it out. We'll have a link in the show notes, and do use the coupon code to save yourself on that course. Also, I just want to, before I forget, I know I will. Next week we're going to try to get Caleb Place on. Caleb is the author of CBFX, which is a great particle effects library, and he'll be joining us. For those of you who don't know, he is actually out of country, or at least out of the U.S. at the moment with his family, and so his internet connection may or may not hold out on us. We're hoping for the best. He thinks that it will, and if it does not, then we'll make an alternate way of interviewing him. But we're hoping to have him.
Plans for the Hangout.
Yeah, we got some backup plans for the Hangout. We're gonna hope to have him on Monday though, because for those of you who don't know, Caleb is he's a teenager and he's written CBFX and a bunch of other stuff, and it's just amazing, phenomenal.
Don't quote me on this, but I think when he first started writing CBFX, he was 14.
Wow.
Maybe I may be getting mixed up with another guy I've been working or talking to, but I think it was 14. He'll correct us anyways.
Yeah, we'll get the full scoop from him and see what's going on. But so let's hope that his internet connection holds out for next month.
Absolutely.
Or next week rather. Okay.
One of those two.
Did anybody on the panel have anything they want? Any announcements? Anything like that?
I do, but you guys go first.
I don't have anything.
Nope, nobody. Okay, go ahead, Ed.
No head shaking. Y'all got to have something. I'm announcing for Brian that Brian's now on vacation, and I hate it. I'm sorry, envy was the word.
What you're calling vacation, I would call every day. So it's.
Oh gosh, you're hurting me even more.
Wow.
Okay, so I'll do my announcement. You can see my screen, and I'm just gonna say, this is Corona. What is it? Well, how can that be happening?
That is a Corona desktop application, looks like to me.
That is a Corona desktop application. And I'm going to let the cat out of the bag because I'm allowed to on the show, not in the forums. So those of you who are watching the Hangout get the cat out of the bag version, which is, I should find it. I'll tell you how to find it, okay? First of all, this is available to you now in Corona. What I'm doing here is I'm running the desktop version of Corona for Windows. So if you have Windows, the Windows Simulator, you don't know it, but you've also got the Windows desktop sort of early version. One word of caution, use version 2625 to 2630, version 2631 through the current release, which is 2638. There's a bug that doesn't allow it to go into full screen mode, which I've written them about. But so you run the latest version, you'll be disappointed. But 2630, that'd be a good version for you to run. That's what I'm running here. And if we hit F11, like we would traditionally from many desktop games, it goes into full screen mode. And you can find this is just go to the directory where Corona is installed, and you should see an executable called corona.exe and another one, if I'm remembering correctly, called Corona Shell. And why don't I just take a look at the shortcut here, and I'll just verify that.
Ooh, and I have a question for you when you.
Yeah, go for it. Yeah,
so
coronashell.exe. Go ahead.
Coronashell.exe. Okay, so I see that the blue there, I guess, is that an image, or is that some sort of container, or
here?
Yeah.
That's just an image.
Okay.
So what you're seeing is one of the things that they're working out right now for the desktop is how to deal with the scaling, dynamic scaling, as you drag.
Yeah, that was going to be my question. Is how's your experience been on that?
I find it to be good. I mean, it's okay if you use a letterbox. You're going to run into the same issues you always run with any scaling. In that you can see is that I'm running 1920 by 1080, and I think I use my super old school 320 by 480 base resolution, and then I know people are like 320 by 480. What's wrong with you? But it's the one where I know exactly how big the pieces are going to be on the screen when I do it, so I know the math. I use it. Uh, and I'm using Letterbox, and you can see there's some bleed area here. Now, one thing is if you're using Corona SSK for Corona, and I pre-calculate the left, right, top, bottom, and I can't remember if it's as released. I'll check before I do the next one, but I believe I have the code dynamically recalculate the left, right, top, bottom on the assumption that you're going to be running this on the desktop and then rescaling this. So as you rescale, SSK figures that out for you, so you can rely on that to always have the correct boundaries of your screen.
Now you could have, if you wanted to, you could have made that a bigger image in the background, right? Could you?
Yeah, I could have. I did not bother to. I simply could have said use the full width of the screen and stretch out. All this is a rectangle. In fact, what I'll probably end up doing is exactly that. I will increase this so it looks better on desktop. This is actually the first time in a week that I've run this on the desktop. So I just wanted to kind of show off the desktop is available and show you something about an upcoming release in SSK before we start.
Sweet.
So SSK, I released it last week. I ran into some problems. There's this button here for watching videos, and on Windows, everybody else it works fine, the devices and on OS X, but on Windows there was a bug where it was the links, it was making them all lowercase, which 99% of the time you don't care what the case of a URL is, but when you're using URL shorteners or YouTube links, it has to be exactly the case that you got out of that you grabbed. So what was happening is the videos you'd click on, and then YouTube would come up and say, I don't know what video you're talking about, and I didn't clue in until I'm like, oh look, all the link widget, the URL, the weird URL is lowercase. That doesn't look right. So that's been fixed and released, and so 2638, it's fine. The link should work. But this week, I'm working hard for the people who wrote me to send them their first invite for the iOS version. And in that version, you will see my initial demos. What I'm doing is I'm working on a series of, so like we do on the show where I try to break down the game mechanic, I'm doing a long series of game mechanics. One-touch taps, one-touch tap and hold, two-touch, swipes, all these different game mechanics. And what I'm doing is I'm taking a game that you can find usually for free and play, and I'm taking one mechanic out of that game and showing how to make it in like 200 or 300 lines of code using SSK. So for example, bird climb, which is just simply a one-tap game where you're sort of like don't touch the spikes, but it goes up and up and up and up. And tapping the screen just gives your guy a little boost. This is about 200 lines of code in SSK. Let's see, two cars. So when you change lanes, it's a two-tap game, and you don't want to hit the circles, and you do want to hit the squares. About 250 lines of code. Bouncing ball. It's the one where the spikes are coming across the bottom, and you're supposed to tap to get your time right. You probably can't see it real well in the thing here, but what you do is you tap, and it speeds up the drop, so you can avoid. You can bounce over, so you get your bounce to go now, and then you can just miss it. That probably doesn't look worth. Let's see. Don't touch the spikes. We know this one. This one's about between 250 and 300 lines of code. They all come out to be about all these one-touch games. 300. That's about the average or lower.
Would you think that's just because the core mechanic itself it changes?
Yeah,
and
once
everything
you
else
solve
is the
the core
same.
mechanic, and for me, SSK, there's the free version, and then there's another version which I'm working on trying to figure out whether to monetize it or how to monetize it. It comes with an extensive additional library of modules that makes things like one-touch inputs and one line of code, so that you can just throw them in there, and then they produce events that you can listen for on your game instead of worrying about doing all the touch handling yourself and knowing how to turn it off and when to turn it off and whatnot. One-liners. One-liner for a joystick, one-liner for a two-touch, one-liner for a one-touch and a joystick on one side. You've seen some games where they put like two buttons in the corner where you tap on one side, tap on the other. That's a one-liner. And a lot of these are compatible with each other, so you can have like that one I just talked about. You can run it twice and say make a 2-button over here and add another 2-button over here, which gives you 4 buttons in the corners of your screen for some control scheme that you might want. So and yeah, and I do little things like touch coalescing, which is something we haven't talked about on the show, but the problem that Corona has, it's not a problem in Corona, it's a problem in the usage by people, is that Corona accepts inputs as fast as the device can respond to them. And so what can occur is you can touch the screen and move your finger quickly and process a bunch of move events all in one frame, which is kind of stupid in the sense that it's good that Corona does it because that way it's highly accurate. But let's say you're doing some heavy-duty calculations and you move, calculate, but it's all occurring in one frame. So the end result is the last one you did, and you really didn't need to do all the preceding ones. So I have a technique which I call touch coalescing, which the touch inputs use to reduce the frequency of the events, and so it keeps your performance good when you're using these events to trigger game calculations. So it's just little things like that to help make your code quicker and run better.
And that's what I like about you, Ed. I like that you're always about the under the hood.
I'm trying, I'm trying, and it's good to be on the show because I get to talk to other folks, and they all push me to think, I got to be a little better, or I could do that a different way. So, all right. So enough of that. We talked about Windows.
So that's desktop. That's desktop. Is that, and that's you're running that on Windows.
Yeah. So I banged for the buck here. I wanted to show the desktop version so folks would know who are on listening to the Hangout would know it's out there.
You haven't done any OS X stuff yet?
I haven't, and because it's you can't see me pointing, but my laptop, which is my OS X machine, sits off to the left side, and so it's a hassle for me to use it. So
have to reach over.
Steps with Xcode there, and I just don't want to deal with it. So when I get the time, I will, and I'm in the beta. It's just I'm not doing a good job of participating.
No, you're clearly on the Windows side. That's cool.
Yeah, so I deal with the thing that's easiest for me, which is the Windows side. I got 2 big monitors. I got a real keyboard and a mouse. That's the way to go.
Gotcha.
So let's get rid of this. Okay, so today.
Yeah. Tell us what we're going to talk about.
So what we're going to talk about is game mechanics for the game called Ichi, and I should have brought up the darn screenshot.
Is that how you pronounce it, Ichi?
Yeah, it means one in Japanese.
Ichi. Okay.
I'm gonna bring it up real quick here. Here it is.
You're the world traveler, so I'm going to assume that that's correct.
Well, I used to speak Japanese. I can't really say that anymore, but okay, that's not what I wanted to do. Here we go. So here's this game. You can get it. Was it free? I think it's a pay game. Nope. It's 99 cents. You can get it on Google Play, and it's probably 99 cents on iTunes. Also, you can play it on your desktop if you have Steam. So it's I think it's available for Windows on Steam. And this was an immensely successful game because, and this is a side note really, but it's why people get so interested in it, I think, is the mechanic is really incredibly simple. It's just this little dot, and it goes around, and it bounces off of what I call bumpers. So this is a bumper, this is a bumper, this is a bumper, and this blue one here can't move, doesn't rotate. The red one, you tap the screen or you click your mouse, it rotates. It's a one-touch game, and the bumpers just turn once for every click. This one up here, you hit it once, it breaks, and then it's gone. So you got all these different kinds of things that you can hit. Like this thing I think is a teleporter. If you hit this, it comes out here. These are things that you need to pick up. And this here, I can't remember if this what goes on with that. I think this is also a teleporter. So anyways.
So this is also very similar to Laser Puzzle, right, Sergey? If not, if not exactly the same?
Oh, no, it's not the same.
It's not the same at all. Laser Puzzle, I'm looking at Laser Puzzle, and it looks very
But
similar in that you're...
I bet you money that he does some of the similar calculations, reflections at a 45-degree angle, or a 90-degree angle, I'm sorry.
Okay. So some elements, but not exactly the same.
Yeah.
Okay.
So I was saying, side note, is that this game was surprisingly popular in that, in addition to having pre-made levels, they put a level editor in here that lets you make your own. And I think users on Steam made something like 40,000 levels
Wow.
for this game, which is crazy. So, anyways, people look at this and they say, "Hey, how can I make that?" And they try and they fail. And the reason they try and fail is when you look at it, it says, "Oh," your brain says, "Oh, that's easy. It's just a 45-degree angle. And when it hits it, it's going to bounce off. It's going to do what I want." I mean, basically, if you look at it, these pieces are all aligned on a grid. Forget about the artwork in the background. But if you look at these, their centers all line up. So in a sense, what's going on here, and I say that because you'll notice that there's an offset here. See how this one's offset?
Yeah.
And that's going to be part of our discussion today. Is people don't see that. Their brain doesn't trigger on that. They're just playing the game, having a good time. And their brain says, "Look, it's a 45-degree angle. I can just make my piece, and it hits it. It'll work." And it doesn't work. And then they're surprised, and they don't know why. So I'm going to explain why. And I'll say ahead of time that we're going to get to the end of this whole discussion. And the takeaway will be some samples that I'll show you, a piece of code where I give like a step-by-step and explain why it works a certain way and it doesn't work the other way and what's going on. And this comes with a rudimentary editor and level loader, so you can make your own levels, and you can see how to make easily in Corona a very basic level editor in just I think it's like 200 and something lines of code for the level editor, and about that many lines of code for the level loader. And I might be off by like 100 lines, but even if it's 300 lines, it's very short. Where was I going with that? So I guess let's just jump in. So all right, so let me get my code up here, and I will show you the code first, just so you can see where it is. This is already committed on the Git, but we'll provide a link at the end of the show, and it's in the Hangouts. I can make that folder, and there's a subfolder called Ichi, or Ichi Mechanics, not Itchy. Mechanics. In this folder, there'll be the README and the main Lua, but there will be 3 files called sample123. There's another one called talk, and game, and editor. And I will go through each of these, but those are the main code files. You'll notice that this uses SSK. Pretty much from now on, as I do these, I'm going to exclusively use SSK because it shortens the discussion and lets us focus on the key components. But as I go along in this discussion, I'll show you a few things that I'm doing so you can understand both what SSK is doing here that helps us and why I'm using it. So let me bring my code over and make sure you can read it. When you download this project, hopefully, if I'm recalling correctly, main Lua will look like this. It'll have my little copyright statement at the top that says, in a nutshell, you can use this stuff any way you want, except you can't tell people that you made it and, in its exact form. And you can't use it in like, oh, shoot, I said jigsaw puzzle there. You cannot use it if you're making a tutorial or a book, not without my permission. So don't basically take my effort unchanged and use it and say, hey, I did this. That's all I'm asking. So it's not a great license. It's not an official, one of the officially recognized licenses, and I'm doing air quotes now. But the point is that little sip of coffee there, is that use it to make games. Use it to learn. That's what I'm trying for here. Okay, so at the top, I do my normal stuff. I change the buffering so I get the output right away in the console. I turn off the status bar because I hate that. I don't want it to show up on the device. One-liner, I load SSK. And then there's 3 sections here. So if I comment this out, it'll be a little more clear. There's this section here, the next section, and the third section. So these are each independent of each other, but I did it this way just to make it easy for you to load them. And so when you get it, it's going to look like this. It's going to be loading sample 1, which is it's the first sample where you look at it and go, that should work. And then when you click it, it doesn't work. And you're like, oh, well, wait a minute. And then I'll explain. So I'll show you the sample, and then we'll go in and I'll do my talking bit. Now this example in Talk Lua, this was written for me to do this discussion. Feel free to look at it, but don't expect to understand exactly what is going on, because it's got all kinds of bits and code in there so that I can just set a number and go, see this? This is what's happening. It'll become clear. So this is my little helper for our discussion today. It's not for you to go, I can extract something from that and use it. No. That's what the samples are for, and the editor and the game running bit. That's what those are for. So let me go ahead and full screen this, or make it bigger anyways. So can you see that okay?
Yes.
Okay, so what are we seeing here? In Ichi, you've got square blocks, among other things, and you've got these triangular blocks, bumpers. And the expectation is that when the ball is moving, if it hits the square block, it's going to bounce back in this direction. It's going to follow this line. And your mind tells you, when it hits this bumper, it's going to go from here, and it's going to be right here, centered on the line, and follow the line, centered on the line, follow the line. It's going to follow this path. Now, one thing I didn't say is the way this is written is when you load it, it's paused. But if you click one time on the ball, the little player guy here, you'll start moving. Also, okay, in sample 2, I think I put a thing in here where you can click on the triangle ones and they will rotate. So you can change the orientation. I'm not 100% sure if I remember that being correct or not. Anyways, so let's click on this and see what happens. Okay, that's right, and this is wrong. Already, we're off. What's going on here? It hit this, but it's way off track. Now, so let's let it run a little bit more. Suddenly, it's back on track, and it's off track again. So I will cat out of the bag first, I guess, here. What's going on is your mind is telling you one thing, but really what is going on is the collision point, which is what changes the direction of the ball, is not here. It's over here. So if this isn't clear, let's go ahead and bring up my talking points.
Is that just because a round ball hitting is hitting the triangle on the edge first before it's hitting in the middle?
Yes, that's why I did. It's really hard to like see it. So what I'm doing is I'm going to bring up the talking points. And it'll make it more clear. Okay, so let's start off with this guy. This one's clear. Absolutely no question what's going to happen. It's a flat surface, round ball. In fact, if I turn on the hybrid mode, let me just do that momentarily. You'll see that here's the outline of the collision shape for this. So it's going to hit this, and here's the collision shape for, it's probably a little harder to see, for the ball. It's going to move along the path, and it's going to bounce back.
And let's make a note right there that oftentimes a lot of people will try and put a square collision on a round ball, whereas in the physics engine you can specify a circular collision detector or circular body on a round surface. So this is the right way to do it. I see it wrong so frequently that I want to make that point.
A new image rect here.
Yeah.
I specify a radius for the body, otherwise this would come out as a square.
Yes.
So, and then people, right, it's good that you mentioned that because I just recently saw some questions from 2 different people in the forums saying, hey, I made a bullet and it didn't bounce off the wall I expected it to. And the reason it didn't bounce off the wall they expected it to is because their shape of their art may have been some appropriate shape, but then they used new image rect, and they didn't
Yes.
specify a radius, and they had this blocky square shape. And then, of course, they had this blocky square shape. And then, of course, they didn't know how to investigate it, or they did not choose to.
And it's a very frequent beginner error that
Yeah.
you just make it a rectangle instead of using the radius in the new rec, and that takes care of everything.
Yeah.
So,
So I'm going to move on to step 2. We're going to look at a triangle now.
so,
Okay,
the,
so
so,
here's
so
the
I just
problem
want
we
to.
had in...
Oh, sorry. Ed. So just the pro tip there then is if you're having problems, turn it on hybrid mode, right?
Oh,
Yes.
absolutely. Yeah.
It'll all become
Yes.
obvious.
Always investigate a little more. And one of the things you can do is simply turn on hybrid mode, which is, if people don't know what we're talking about here, is, where is it? Talk, physics, set draw mode, hybrid. Make that a little bigger so you can see it. This bit right here. After you start physics, set hybrid mode, and you'll be able to see the collision boxes. I've already turned it off, but it was that green bit, and it will also show you a little... let's just turn it on. It'll also show you these, probably really hard to see, a little line here and a little line here, which tells you the orientation of the body. So positive X, positive Y, going down.
Cool.
So if you've rotated your group, that's when you'll say, oh, if these are ever not at a 90-degree angle to the screen like this, then you've rotated your group. It's not the body, I don't believe. I could be wrong. Now I have to investigate, darn it. Okay, pretend I didn't open my mouth there. Okay, so this is where we were. Our mind is telling us the ball's going to hit here, and it's going to follow this track. But then again, we do this, and you'll notice here I'm leaving a little trail behind. You can see exactly where it went. That is what happens. So why is this happening? If you run step 3 in the talk, it'll put up a couple of dots here. So what's occurring is this thing is moving along, and let me see if I can stop it when it's doing it. Okay, there it is. So it's had the collision, and the collision doesn't happen here like we're expecting it to. It happens here. So our mind says it's going to be here, but it really occurs here. And as soon as it hits here, what happens? This is a 45-degree angle. It's going to change the direction of this from this. It's going to change it by 90 degrees, basically, if it's coming in.
Horizontal.
Is that correct?
It's going to go from horizontal to vertical.
Yeah, basically it's going to go from a horizontal motion to a vertical motion, as we can see. So how do we fix this? The way we fix it is we change the point of impact. What we want is we want the body to move through this line, and we want it to change direction when the center of the body, the moving circle, is in the center of our track or our grid. So the only way to do this when using physics, via a collision, is to move the point of impact. So what we do, step 4 in the talk code, I'm changing things here, right here. So talk run 4, and I should have said that at any time you want to render hybrid mode, you could set this to true, but I'm going to leave it off for the most part. So we're on step 4. So step 4 shows the square block, which is sort of our reference for how the grid would be laid out. The red one here is our original incorrect sized body. And this one here is actually the correctly sized body, which leads to another problem. But before we get there, let's just prove that this works. Come on. Da-da-da. Okay, good. So now what we've got is follows the track exactly. We know that if we use this technique, no changes, we could build a grid, we could put our objects placed correctly, and everything would work. I mean, it would follow the orientation. However, having done this, we've produced for ourselves an issue. How do we calculate the placement of this shape? Additionally, it looks terrible. This block is about 1/3 of the size of this block. So I just want to stop at this point and say, for people who are making a game that is not like Ichi, if they want to make an Ichi-like game, our discussion continues. But at this point you can stop. the thing that you need to take away is if you're trying to get this kind of motion, you need to consider the point of impact versus the angle here. And it's the discussion we just had. We had to move the point of impact further away so that the point where it changes direction is here. And this is the thing that people mess up all the time when they're thinking, okay, I'll just make an angled surface and it'll bounce, and then they're like, wait, it didn't bounce the way I expected. It's slightly offset. And the reason is the collision point was further down. It's over here. All you got to do is move it further away, keep it on track. So what about Ichi? Like I said, this piece is very small, and if we were to make our game like this, it would look kind of wrong, kind of ugly. Now, if we go back and look at their implementation, you'll notice that this block, although not exactly the same size as this block, is pretty close. It's like maybe 10% shorter. And they did this thing where they rounded the corners, and you can't see it in this static image, but I'll show it to you too, is that these pieces throb. They get smaller, they get bigger. They get smaller, they get bigger. And so all of this, slightly smaller, and the throbbing, the rounded corners, is combined to help trick your brain, and there's one more thing, to trick your brain into thinking, they're all the same size, or close enough.
Hey, Sergey, did you have something you wanted to throw on that?
Yeah, I want to share my thought, like what else could be done. As Ed pointed out, this is a physics problem, and one way to solve this is to not use physics. But if you want to use physics, you can actually combine physics and not physics methods together. You can use pre-collision event with a platform, like normally sized platform. And when that happens, you take control over the ball, over the object that collides, and you can translate it to the center of the figure, despite the actual boundaries, and then do another transition from the center. And when it leaves the object, you give it actual physics properties like speed and stuff.
So, oh my fire!
Oh, is that kind of where we're headed?
One thing on top of that, though. Everything Sergey said, but you want to make the body a sensor.
Yeah.
I've heard a lot of, or not a lot, but I've heard several discussions where people are saying, well, you don't need to use a physics engine for that.
Yeah.
So is there a benefit to one or the other, or is it just 6-1, half dozen?
If you have a strictly grid-based game, then using not physics would probably be better, because you would not end up with some weird behaviors of your objects.
I'd also want to say that Sergey's solution he did steal my fire, but I'm glad he brought it up.
So you have it.
I think I said it already at the beginning of the show, but this solution that I've presented and provided is not the best solution for making Ichi. The one that Sergey just mentioned is the correct final solution. It's to use a combination of physics and some other mode of aligning and changing direction. And the reason is, and to answer your question, Charles, is that physics is great when you want to have nice feedback and things that feel natural, and you don't care about 100% accurate precision all the time. The problem with physics is one little tiny mistake, like I was going to mention this, is in the sample code when I make the big rectangle. Oh, I'm showing you. Let me show you the screen here. I'm sorry, I'm pointing at it. When I make this big triangle, I use a feature of Corona called Use Outline. So instead of making the shape for the body, I just say, hey, look at the texture, and anything that's transparent, assume that that's going to be the outline of the body. So the body is the opaque part. The translucent part is the non-existent part of the body. But the problem is that creates an angle that is not exactly 45 degrees, and because of that, the collisions go wrong eventually. They get slightly perturbed. Another thing is timing errors and placement, alignment errors, and subpixel changes in the grid and little details like that can all affect the physics calculation, which is based on floating point numbers, and it's got to be extremely precise to get this kind of response, which is come in at this angle and go off at exactly 90 degrees.
So if you're willing to do the calculations yourself, then you're saying you don't necessarily get all the other baggage?
You make it sound hard, but those calculations are not hard, really. What Sergey is saying basically is make this thing a sensor, and what that's going to do is it's not going to have any response then. Response being is that it's not going to bounce, it's not going to push, it's merely going to detect the collision. So it comes in, it detects that it has a collision, and at some point in your code you say, okay, either immediately when it makes the collision or momentarily afterwards, I'm merely going to, let me start this over again so you can see it. So at this, say like at this point it had the collision, then your code could take over and say, move the body over to the center, say, oh, it was moving left, that means now it needs to move up. So you do that little bit of part where you change the velocity, you recenter the piece where it's supposed to be, and everything is good. You maintain the correct alignment of your path and your pieces. It's not a hard calculation.
Okay. Well, let's continue with the thing here.
So before I lose my train of thought here, sorry. Okay, so what did we discover here? The first trick for this is to move the point of collision such that the center of the body is in the center of our virtual path. But this is not good because it's kind of ugly. So let's make it a little better. So step 5, the other thing you'll notice about Ichi is that the ball is not the same size as the blocks or the bumpers. So as previously in my sample here, these were not exactly the same size, but this was very close to being as big as the full-on square here. And that's not what you want. I'll show the trick, the code, in a minute, but my trick to doing this calculation is based on the radius of the ball. The smaller the ball is, the closer this shape can be to the size of the full block. So now, this ball has a much smaller radius. As you can see, the point of collision is almost now at the point of the path, which gives us visually this impression that it's bouncing off the center and staying on the path. But in fact, it's not. And I just want to reiterate here is if you look at this Ichi example right here, you can see that these two blocks are misaligned, and that is because these blocks are slightly smaller than the full-on block. So let's run it and see that it still in fact works. Okay, good. So that still in fact works. Point of collision is here, center is here. As it has the collision, it stays on path. Let's make it slightly better. I think I need to go into hybrid mode at this point. In fact, let's do hybrid mode, staying on step 5. And yeah, I've already applied the trick. So in step 5, while the physical representation, the drawing part, looks this big, it's really hard to see, but the radius of the body is 80% of the radius of what I've drawn. In other words, it's smaller. So what that lets me do is make this bit real tiny, but approximate, because your eye can't track all this. It's going to look like the collision looks right, but it doesn't.
So you have a normal size ball, but your
body is smaller.
The body is smaller. So
the physics body is 80% the size of the ball, which lets me make this piece bigger, and the collision point happens closer to the center. And because the eyeball, it's all blown up here, but when you look at it in a smaller puzzle piece size, on your little screen, you can't tell. But this is version 6. As you recall, one of the other things they do in Ichi is they throb the body, which again fools the eyeball. What people need to realize is that in Corona, when you scale when you scale the object and it has a body attached, the body does not change size. It does not scale with the scaling. People they trip up on this all the time. They create an object, They add a body, and then they scale it to like twice, and they're like, why is the body not coming along? The reason is that's just the way it is. I don't know what the reason is, but I'm sure that it's difficult to do after the fact. So if you want the body to match the size of your object, you have to have scaled it previously.
So you're saying I'm just might make sure I'm clear. So you're saying visually, when you make the object look bigger, the body itself is still the same size.
Yeah. Let me make
the original size.
Where is the code? Let me find the code. Oh, I'm looking in the wrong place. Hold on. Let me find the throbbing code and make it really obvious.
Because that would definitely be a point of confusion. Like, why isn't it acting the way I think it should?
Okay. Now I made it 2 times larger. So you see how big the body's getting?
Yeah. Now it's obvious.
Part?
Yeah.
That's the physical body. I keep saying body. The image gets larger, but the body stays the same.
The physics object stays the same.
Yeah.
I think if you apply -1, it will change.
Say again?
I think if you apply -1, like X scale -1 or Y scale -1, it will flip. So it's...
Right. Absolutely. Okay, that's right. Sergey is saying is if you use the negative scaling flips the image, but it also flips the body. So Corona's smart enough for the body to track the mirroring or the flipping of the image, but it's not going to adjust the size of the body relative to the scale, just the orientation.
Interesting.
So,
okay.
So we've given 2 more expert tips here on dealing with the physics engine. First of all, changing the scaling of the physics object itself so it's slightly smaller than your object to improve your collisions, which is what Ed did with the circle. And then that scaling doesn't happen post adding the physics body to a display object.
Absolutely. So as we can see, this is better, and I'm just going to run step 7, and then I'll show you the trick code, and then we'll go and I'll show you the editor and the other thing. So, okay, so this is step 7, and let me turn off the physics body, or the hybrid mode. Now, if we watch it, it feels better. Now, obviously, it's still blown up, so we can see how it overlapped. But if it was moving at a higher rate of speed, you wouldn't really necessarily notice that. In fact, just to prove this point, I'm going to go back. I'm going to turn off the talk code. Let me do this so you can see what I'm doing on the thing here. So turn off the talk code. I'm going to run the sample, and I will run sample 2 by itself. Now, if we run this, no, I didn't do the throbbing. Ding dong. Oh, even without the throbbing, to my eyes, even at this scale, it still looks pretty good.
Yeah.
And just so you understand the difference, you can run sample 3. What that does is run both sample 1 and sample 2. And this is the original one, and that had our problem where it would collide incorrectly. But all of the action now will occur using the bodies from sample 2. And it's got a little bit of a lag problem there. I'm not sure what's going on. But so that demonstrates the visuals of what's going on. So let's take a quick look at the code, and then I will show you the editor. Okay, stop running out. Okay. Now, I'm going to leave a lot of this up to the listeners as homework, but I'm going to give you an insight into a couple of pieces. Now, the code here is available to you. It's commented. I think you should be able to figure it out. I just want to run you through what's going on here. First of all, sample 1, it's a module. So I start off, I make a table, and then below I will attach the function run to sample, and I will return sample. And so later in my code, I can say local sample equals require sample 3 for sample1, and then I can call the function that was attached, which is right here. So we've done this before in previous shows. Let's go back to sample2, which has got the solution in it. The other thing is, as we proceed here, I localize a bunch of SSK functions. SSK comes with replacement calls for display new circle, display new rect, new image rect, new sprite, etc., etc. So these are my versions. EasyIFC is a library that allows me to create one-line buttons. mrand is just a shortcut or localization of the random function. IsValid is a function that I wrote and inserted in the display library that allows us to check an object to make sure that it is still valid, it has not been destroyed yet. Because what you can get is you can have an object that has been had remove self called, and yet the handle is still available until you set the handle to nil. The memory doesn't get freed. So in essence, the Lua part of it still exists, but the display object part has been destroyed. And then if you try to do something with physics or set the X value, it's not going to work. So this little line of code here, when used with SSK, will validate that the object is in fact a display object and can be operated upon. Angle line is just it's an addition that I have, so you can specify the starting point for a line, the angle that it should be drawn at, and how long it is. So it's just a variation on doing lines. And moving on, the local variables, which I use throughout my code below. The size of the piece, which is 40 pixels. The size of the ball, which is 20 pixels. So that would have a radius of 10. The ball speed, moving at 100 pixels per second, and I calculate it below in my code. Let's see, I had ball size twice, that's nice. Anyways, ball radius, 0.8, why am I doing this? Multiplied by the ball size divided by 2. And then, once I know the radius of the ball, and here's the trick, it's my favorite, the square root of 2, and I'll show you a picture to explain this. But my disclaimer here is the math is something you just need to do it once on your own or twice, and pretty soon you'll just say, ah, that's the square root of 2 thing. I just got to use that trick, everything works. I know it's not satisfying, but I can't remember the exact steps. I've done it so many times and so long ago that now I just say, oh, square root of 2, boom, done. Don't need to remember the steps. The trick is, knowing the radius, we want to make the shape smaller. And the way we do that is we calculate an offset where we're going to shrink the size of the object by 2 times the offset, and then we're going to move it left and down or right and down, depending on the orientation. I'll show you this. Let me show you. So what we've done here is we've shrunk this by 2 times the offset and then moved it left by the offset and up by the offset. And that puts the collision point in the right place. And visually it's oriented correctly and it looks right. Let's see, so the offset is just the square root of 2 divided by 2 multiplied by the radius. And I'll show you the picture in a minute. And so what we're doing here is we're using the good old Pythagorean theorem, which says that when you have a triangle and you want to figure out A, B, or C out of this triangle, and you've got 2 of the pieces, you can figure out the other one. In other words, A squared plus B squared, that's this equation right here, is equal to C squared. In this case, with a circle, we know that A and B are the same length. So in this case, the Pythagorean theorem says that C squared is equal to 2 times A squared, or if you prefer, 2 times B squared, since they're the same quantity. So then we can figure out A, which is what we need, because we want to move we want to move the collision point this far left and this far down. So we need to figure out this quantity right here, A and B being the same, and then apply it somehow. So A is nothing more than the square root of C. Now, the trick that I always use, and people, this is where they all trip up, collapse it down to the unit vector case. That is where C is equal to 1. That simplifies this whole equation to saying that A is nothing more than the square root, that's wrong, I'm sorry, 2. Square root of 2, make the radius 2, so we don't deal with imaginary numbers, and then divide everything by 2, and it makes the math simple. And I think this is where I'm starting to trip up in the discussion. The thing is people just need to experiment with this and sort of like play around with the numbers, and they will see that the trick always works.
Well, luckily you've provided the code so they can do that.
I've provided the code so you can modify the code to your heart's content and see what happens. And don't forget, it would really help a lot is turn on the hybrid mode, and then you can see where the body is relative to everything else. And it should start to become clear as you play around with values. You can change the piece size, you can change the ball size, you can mess around with the ball radius, and then rerun it over and over and see what's going on. And what I would do is change the code in sample 2, but run sample 3, because what that'll do is it'll run sample 1 in the background. And then when you make changes, you'll see this part change, but the original body will stay the same, and so it'll become a lot more clear visually, which is, I think most of us are visual thinkers, and it'll come clear. Sorry.
Okay.
Okay, so real quick, and then I'll show you the editor. Sample 2. Couple of bits here. 2 bits, and then you need to just download the sampler for SSK and take a look at the core examples where I go into more details on how to use these things. One of the things I'm doing in my examples is I'm using display groups to separate what content is on top of what content or below what content. However, SSK comes with a library, really more of a, call it a library or a module called Quick Layers. And Quick Layers basically says, call this function, pass in a group, or if you don't, you can pass in nil, and then a list of names. And what it will do is for each of these names create a display group. The first one will be on the bottom, the second one will be above it, the third one will be above that, etc. And they will all be put into the group that you passed. And if no group is passed, they will be put into the default display group, which is current stage. And then later, it will return a group called, which we can store in a variable called layers, and then we can merely say layers dot and the name that we chose as our group. So we can pass this in to display new image rect or my replacement, and this object will be created in this group, which is above underlay and below overlay. If that makes sense. Hopefully that makes sense. There's an example in the sampler showing how this works and demonstrating the difference between doing with it, using it, and not using it. The only other bit I want to point out here is the reason I use new image rect mine instead of using the one that comes with display new image rect is because in one line of code, which I consider this to be one line just with carriage returns to make it more legible, I have created the rectangle, placed it in a group, chosen its position, specified the image it's supposed to use, chosen the size, which is the width and height, or I could have said width and height. There's a lot of different ways to specify these details. But there's a shortcut, which is basically saying size equals something, and that says make the width and the height the same and make them equal to this. And this little table here takes a bunch of things. I could have said make the fill color gray. There's a bunch of short codes that come with Corona: gray, orange, purple, etc. Or even shorter, like the basic ones: white, black.
So sort of a properties table for the.
This is a properties table for all the visual. This is what's called the visual parameters table. It specifies to the builder what it should look like and how it should look. The next table you see, again, all in one line of code. If you provide it, you do not need to provide it, but if you provide it, you could simply provide an empty table like this, and that says create a default body that has all the default body parameters in one little two bits of code there. Just open bracket, close bracket. You've replaced a whole bunch of code that says add a physics body, make it dynamic, give it a bounce of 0.2, yada yada yada. And even here, it's smart enough to say, oh, it's a circle. So if this had been new circle, it would say, oh, it's a circle. I need to put a circular body on it. So it does all these little things for you. Or you could specify specifically a radius, make sure it's fixed rotation, because I didn't want, when the collisions occurred, I did not want the body to rotate. I set the bounce to 1, friction to 0. I set the isBullet property. And here's another thing. When you specify bodies in using the traditional physics add body, you can specify some of these fields as in a table that you pass to add body. But for SSK, even if they have to be specified subsequently by attaching them to the body, so some things like I think isBullet is actually, you would have to say ball, and I could be wrong, but let's just say that I'm right in this case. There are fields like this where you set a property after the fact, but you can't pass it in. That's not true for SSK. SSK, all of the parameters can be passed in, and it knows how to correctly apply them. So just my reasoning here. I don't like to type out all this code. It makes it hard to read. Really, all we wanted to do for the example here was create a ball with a body and just move on in our thinking. And that's why, from now on, I'll be using SSK in the examples. Okay, so I think that's about as far as I want to go with looking at the code. I strongly encourage people to dig into it, change the values, run sample 3 because that'll give you the best perspective on what's going on. And then when you are ready to go ahead and run the editor. So comment this out. Run the editor simply by uncommenting that or adding a couple of extra dashes. Bring it up. And here we have the editor. And what the editor is a drag and drop editor. And I will give you the nickel tour on what's going on here. This gray block here is the editor region that represents the board itself when we play the game. What I've done is taken a group, moved to the center of the screen, put a rectangle in it, drawn a grid of shapes inside of it, each shape representing a node in the possible paths that our Ichi clone game can have. And then in the group that contains this subgroup, I've placed little buttons and attached a listener that lets me drag and drop them. And then when I release them, it checks to see if the shape is near to one of these nodes or far away. If it's far away, nothing happens. If I drag it and drop it and it's near a node, like this, it snaps to the nearest node. It does a little trick calculation, which you'll see in the code because this is scaled. So it has to figure out where's my position relative to the actual dot, and it puts it there. And then the dot will keep track. I set some fields on the dot and on the piece so that they know about each other, and the shape knows that it is related to this position. Because later, let's just do some things here real quick. Oh, and you can place things, and then when you click them, they will change their orientation. And let's just do this, and then you can place the thing, and let's make it move like so. Also, it's worth noting that if you put a piece in here and you drag another piece and drop it on it, it will remove it, or you can drag it and drag it off. It will delete it. You can save it, and this will put it in a table. The table is located in the sandbox in the documents folder in a file called mylevel.json, which if we look at it, looks like this. This is for you to dig into and examine. And then if we, let me get this here so you can see it. If we click the test button, what it will do is it will load the game module, game.lua. It will destroy this group and all of its contents, so everything gets removed. And it creates a button up here, which then, oops, I placed too many objects. Places a button up here so we can go back to the editor. And that's pretty much it. I would encourage people to dig into these bits of code. They are pretty straightforward, relatively well commented, and as you'll see, it's super simple to make your own editors in Corona, which you can do to extend your games later right on the device, because everything I just did there works on the device. You can actually build this for your device, install it, run the editor, the exact sample that I have here, and make and save levels and restore them and run them.
Excellent. Now you mentioned a level loader. Was that?
Yeah. So the level loader is Game Lua. Now let me just show you what I meant there. So if we look at the editor starts here. I just called the table editor, so it's a module. You know, it's just using this table trick to create modules. But then later on, when you click the test button, it will call onTest. onTest is the listener for the test button. What it does is it calls the listener for the save button that does the saving. There is it. It's this bit right here. It's all it takes to save your level. And then removes the editor group. That's that bit that I was talking about right here. Actually, the editor group contains everything on the screen, and this little bit here is what I call in the file the level group. And then I require the game module, store what is returned in game, and if we look at game is nothing more than another module with some physics code, the localization, my locals, a function for loading the level, another one for drawing the bumpers, stuff that you can dig through. So it loads the module, and then it runs, and I pass in the name that we've stored, and this is to give you a sort of like a heads up or a leg up on modifying this code to accept otherwise named levels, because if we wanted to, we could, where is it? There we go. I could name that Bob. Change this code right here. And this is breaking the functionality of the editor, but I just want to demonstrate what's going to happen. So the editor loads this level. Let's put some more stuff in here. And yet when I run test, because I modified my code just now, it's going to load Bob. Bob doesn't have those pieces that I just added. So my point there is that I gave people who are going to really dig into this a hint on how to modify this code to start loading otherwise named levels. So again, loads the module, calls the run function. This is what I meant by the level loader / game running code. And just for the purpose of using it with the editor, this returns a group that everything is contained in, so that we can create a button in the editor called edit again. And when we click this, it'll destroy this and rerun the editor. So you can go back and forth real quickly.
Okay, yeah, because I could see how you could take that, even if you didn't want to include a level editor in the game per se, you could use it to, like
make
you just
your levels.
showed, yeah, make all your levels, visually, save them out, rename them as different files, and then when you wanted to go in and create a scene, create a grid of buttons, and then just link them up.
Yeah, this is exactly how I do my games. I don't hand place stuff and like calculating, oh, it needs to go 2 pixels to the right. I use tools. if I need a tool like this, I make a tool. This literally took like, I don't know, 45 minutes, an hour to make? Not even that. Done. You've got yourself a ready-made editor, and if people follow, they don't need to use SSK, okay? But what they can do is, because SSK makes each line like shorter, they can see basically like the thrust of what I'm trying to do here, and they say, aha, I make a piece, I make a builder, I make a little table entry that keeps track of the parameters that I need to reproduce it, save that, load it, have a builder that looks at those parameters, done.
Yep.
The concept is straightforward.
Cool. Awesome. Well, I love this, and yeah, everybody, like I said, needs to go download the code and just play with it. Pick it apart. See, first of all, see how it works, and then pick it apart. Change the values. Make it your own. Understand
Absolutely.
how internalize it.
Make it your own.
This is good stuff.
Make it so. Make it so, number one.
Make it so. All right. Well, thanks for that. I appreciate that. That's good stuff. So again, like we said before, we're focusing in on the core mechanics of the game, not necessarily the whole complete finished publishable aspects, like all the scenes and the splash screens and the game overs and all that stuff like that. We've already done that. You can check those out in the previous Hangouts that we've done. Like 126, I think, is kind of the starting point where we started having these game mechanic conversations, and so you can go check those out. But that's it. So thanks for being here this week, and be sure to come back next week, and we'll be talking to Caleb Place about CB effects and his particle effects library, and we'll have more talk about game development using Corona SDK. Until then, have a great week and happy coding. Oh, I gotta push the button.